Good afternoon, ma'am. I'm M. Sai Pawan from CSA AML department, bearing roll number 239518667. And today I'm here to discuss about a complex engineering problem statement in the subject of theory of computation. And my topic is about construct PDA for palindrome strings over AB. And let's get my session. And before entering to the presentation, let's see the content of the presentation orally. First abstract and then problem statement and followed by introduction, requirements, prerequisites, technologies used, literature review, methodology, result and discussions, and conclusion and future scope. These are the contents of the oral presentation. Let's see one by one each. Abstract. A push-down automation is a computational model that extends the concept of a finite automation with an additional stack-based memory, enabling it to recognize context-free languages. This project focuses on constructing a PDA that accepts palindromic strings over the alphabet A, comma B. A palindrome is a string that reads the same forward and backward such as ABBA or ABA. The designed PDA utilizes its stack to compare the first half of the input string with the reversed second half. During the first phase, the PDA pushes input symbols onto the stack. Upon reaching the midpoint, it transitions to a comparison phase where each subsequent input symbol is matched with the top of the stack. If all corresponding symbols matches, the PDA reaches its accepting state, confirming the string as a palindrome. And let's see, this is a problem statement. And the problem statement is the challenge is to construct a pushdown automata that can recognize and accept all palindrome strings formed using the alphabet A, comma B. The palindrome is a string that reads identically from left to right and right to left, such as ABBA or ABA. Traditional finite automata cannot identify such patterns due to their lack of memory to store and compare symbols from different parts of the string. And let's see the introduction of this problem statement. Uh, a pushdown automata is an abstract computational model used to recognize context-free languages. Unlike finite automata, which have limited memory, a PDA includes a stack that allows it to store and retrieve symbols, making it capable of processing languages with recursive or nested structures. One classic example of such a language is a set of palindrome strings over the alphabet A, B. A palindrome is a string that reads the same forward and backward, such as ABA or ABBA. Recognizing palindromes require memory to compare the first half of the string with the second half in reverse order, something a finite automation cannot achieve due to its lack of memory. The PDA uses its stack operations push and pop to remember symbols from the first half of the string and matches them against the second half. Theoretical requirements. Alphabet A, comma B. The set of input symbols for the PDA. Stack of alphabet A, comma B, comma Z0, where Z0 is the initial stack symbol. States a finite set of states including start, intermediate, and final states. Example Q0, Q1, Q2, and QF, where Q0 is the initial state and QF is the final state. Start state of Q0. The PDA begins computational from this state, accepting states. If QF, it indicates successful recognition of a palindrome string. Stack operations. Push and pop operations are required to store and compare input symbols. Transactions function defines how the PDA moves from one state input symbols and stack content. Prerequisites: basic knowledge of automata theory, understanding the difference between finite automata and pushdown automata, familiarity with deterministic PDA and non-deterministic PDA models, concepts of states, transactions, input symbols, and acceptance conditions, understanding the stack operations, knowledge of how push and pop operations work in stack in data structures, and awareness of how a stack helps to store and retrieve symbols of comparison. The technologies that are used in the software tools and simulators are J- JFL and JFLab, Create Java Formal Languages and Automata Package, a widely used educational tool for designing and simulating PDS, DFS, and NFS and grammars. Help visualize stack operations, transactions, and acceptance steps for palindrome strings. Automata Editor, tools for modeling automata and verifying correctness through simulations. Python or Java, programming languages that can be used to implement PDA language logic programmatically using stack data structure. Graphic Viz or Drive for creating state diagrams and visual representation of the 2D transaction. These are the technologies that we use in this problem statement of palindrome, PDA palindrome, and literature review. These are the different papers that have been researched on different on these papers in the topic of my problem statement. And this is the demonstration DFA and equivalence of DFA and NFA methodology. The methodology of constructing a pushdown automata to recognize palindrome strings over the different alphabet A, B involves a systematic approach combining theoretical modeling and step-by-step simulation. The following stages explain the process of structured manner problem identification. The goal is to design the PDA that accepts all strings over A, B that reads same forward and backward. Since palindromes are context-free languages and not regular, they require a PDA, a computational model equipped with a stack to store and compare symbols effectively. Result and discussions. The design pushdown automata successfully recognizes all palindromic strings over the alphabet A, B through the use of stack-based memory. The PDA can compare the first half of the string with the reversed second half, effectively handling both even and odd length palindromes. Using the JFLab simulation tool, multiple input strings are testing to verify correctness of PDA, and the PDA accepted valid palindromes and rejected non-valid palindromes, confirming the accuracy of the theoretical model. Let's see the future scope. The study and construction of pushdown automata for recognizing palindrome strings over A, B opens several avenues for future enhancements and practical application. Although a current model accurately identifies palindromic patterns using stack-based computation, there are multiple directions for extending its functionality and real-world relevance. Deterministic PDA optimization. While the existing model uses a non-deterministic PDA, future work can focus on exploring methods to approximate palindrome recognition using deterministic PDA structures or hybrid automata such as optimization could improve performance and reduce non-deterministic branching in implementation. And as I said, these are the references of different research papers that have been used in this project. And thank you.